Good morning everyone. So today we are continuing the IC engine classes. So last class we studied about brief introduction of IC engine classification, heat balance sheet, then measurement tactics for air consumption, fuel consumption, then frictional power measurement using different methods, then Morse test. So these many topics we have covered in the last class. So today we are discussing about class combustion in SI engine as well as detonation and factors affecting detonation for SI engine. So today we will cover about SI engine. In the next class we will cover about CI engine and alternative fuels and ratings of the fuel. So these many topics we will cover in the next class. So today we are discussing about SI engine. Carefully listen to this. So once you understand the concept of SI engine, then CI engine will be very easy to understand. So carefully listen to the class of combustion of SI engine. So we will come to combustion of SI engine. Before going to the combustion of SI engine, we should take care of what you mean by SI engine. So as already you know how SI engine works. First charge, that means fuel plus air during the suction stroke, it is going inside the cylinder. Then after suction stroke it will be compressed charge, that is fuel plus air will be charged, that is together it is called charge. So that will be compressed. So pressure will rise, temperature will rise. When piston reaches your top dead center, spark will be produced, and due to that spark, combustion of this fuel will take place and power will be produced, and that will be power will be transferred to the piston. So we will have the expansion stroke or power stroke, then we have the exhaust stroke. So today we are concentrating about only the combustion part. Remember, only that combustion part. At the end of compression, the whatever the combustion will take place. So how it is going to happen. So in a SI engine, very important, because due to combustion itself the power has to be produced. So that means whatever the energy it is having, fuel, all the energy has to be converted into heat energy. We are trying to improve that combustion efficiency. So you should know how that process is going to take place so that maximum power you can utilize. So as the momentary spark will be ignited for the homogeneous cylinder mixture, so a thin thread of flame will be produced. That means one flame nucleus will be produced. From that flame nucleus, we are producing that flame front, and that flame front has to rapidly it has to cover entire combustion chamber, so that all the fuel has to be burned and power has to be produced. So now we will come to know that combustion will be dependent upon the propagation of the flame front. That means once the flame nucleus or flame thread is formed, then the flame front will be covered, and that flame front should be rapidly it has to propagate to the entire combustion chamber. So what you mean by flame front? Before going to that one, you should know what you mean by flame front. So flame front is the boundary or the front surface. Carefully listen what you mean by flame front. It is the boundary or flame front surface that separates burned gas from the unburned gas. So we have the one closed chamber. In IC engine, combustion chamber is the closed chamber. Once spark is ignited, flame nucleus is formed. From the flame nucleus, flame front will be formed. That is the separation between burned gas and unburned gas, one boundary is formed, that is known as flame front. So that flame front, how much speed or how much propagate to the entire combustion chamber, how fast it will propagate, that is very important. So now you came to understand what I mean by flame front. We should know about flame speed. So what do you mean by flame speed? The speed at which this flame front travels entire combustion chamber. So it has to travel entire distance in the combustion chamber, how much fast it will travels, that is nothing but flame speed. So this flame speed will affect combustion phenomena, power developed or pressure developed inside the combustion chamber. So this burning rate of the fuel, burning whatever the fuel will burn, no? So that will depends upon flame speed and shape of the combustion chamber. Two important factor this burning rate will be depends upon, that is the flame speed, how much fast the flame will be travel, and shape of the combustion chamber. So depending upon these two, burning rate will be depends. So this factors separating for this flame speed will be turbulence, engine speed, compression ratio, initial temperature and pressure, failure ratio. So turbulence means how much turbulence we are created between the fuel and has, so that it has to properly mix and combustion has to take properly, and flame speed should be travel faster. If more turbulence is there, flame speed will be more faster, it will travel. Then the engine speed, if the speed is high, the turbulence will be high, so hence flame speed will be high. Compression ratio, once again, if higher compression ratio means we will create a more turbulence, hence flame speed will be high for the higher compression ratio. If the initial temperature and pressure, if it is high, then means more temperature or more pressure if it is there, that means flame speed will be higher. And fuel air ratio, if it is richer side, then we can have the more flame speed than the linear side. So because linear side will have the dilution effect and the speed can be reduced on the linear side. So hence fuel air ratio, if it is on the richer side, then the flame speed will become more. So these are the factors which will affect the flame speed. So now you came to know about flame front and flame speed. Next, in the normal way, how the combustion will take place after the compression, that is A to B represent compression, B to C your combustion, C to D it represent expansion. If it is theoretical way of representation of P theta diagram will be like this. Theoretically, A to B, when piston reaches TDC, combustion has to occur at constant volume. So sudden pressure rise will be there. Within that constant volume, all the fuel has to be burned. Then from C, that is from TDC to BDC, when piston is moving, it has to transfer the power, that is expansion stroke has to take place. In this way, your pressure curve will be there for a theoretical one. So A to B represent compression, B to C is the combustion, C to D is the expansion. That is the theoretical way. But in actual case, combustion won't take place at the constant volume. It has to take some time before TDC and after TDC, so that your pressure curve will be different. So we have certain stages of combustion. In 3 stages, combustion of SI engine will take place. The first stage is called as ignition lag or initiation of a flame. Second stage is called as flame propagation. Third stage is the afterburning stage. So afterburning will be there for entire case, because once expansion is over, for unburned fuel will be remaining, that has to be burned in the expansion stroke itself. So afterburning will comes in the expansion stroke. But 2 major stages in an SI engine will be ignition lag or initiation of flame and flame propagation. Now we will go through these 2 stages, how it will be. Before that, how actually P theta diagram will look like. This one will be the theoretical, how actually it will look like, we will see that one. So this is your actual P theta diagram, that is on your y-axis pressure, x-axis crank angle. This is the TDC position, this is the towards BDC, this is also towards BDC, this is for compression, this is for expansion. So your pressure curve will be like this. So at one point you will give the maximum pressure, so that is the peak pressure we will call. So this point A that represent initiation of spark. Actually, theoretically, initiation of spark should take place exactly at TDC and combustion has to finish exactly at TDC only. But it won't happen in the actual case. So initiation of spark will take place at point A. Once initiation of spark will take place, it has to produce first flame nucleus. From the flame nucleus, flame front has to be produced. So only small portion of fuel will be burned during this show. So there won't be a much pressure rise during the portion A to B. But when it reaches point B, there will be sudden pressure rise will be there. So that is the point B will separate between sudden pressure rise to the normal pressure. So this AB will represent initial state, that is the formation of your flame front. Formation of flame front. So this is exactly the chemical reaction. Chemical reaction purely depends upon your spark and fuel. So how the flame has to produce, so that will take some amount of time. That is known as initiation of flame, or you will call it as ignition lag. So once flame front has been produced, it has to travel. It has to travel for the entire combustion chamber. So it will traverse entire combustion chamber. That means more amount of fuel it will burn, so that pressure rises will be keeps on increases. So it will reach us until it reaches maximum pressure. Till that stage is known as flame propagation stage. Once it reaches the maximum point, that is the point C, from there the stage is called as afterburning. That means once it reaches maximum pressure, means almost all the fuel has been burnt, so that it can reach its maximum level. Then whatever the remaining fuel will be there, that has to be burned during the expansion stroke. So because during the expansion stroke, volume will keeps on increases, and pressure can be increased during that stroke. So we can see the pressure will keeps on decreases. So whatever unburned will be fuel will be there. Sometimes it will burn in the expansion stroke also, because of availability of air and some other parameters. It will depend. So this is known as third stage, that is the afterburning stage. So here one is the motoring curve. So already we have discussed motoring test like that. So this curve is without fire, means without combustion of the fuel, how your pressure curve will be there. So B will be the where it will separates between the actual cycle and a motoring cycle. So where sudden pressure rise will be there, here pressure rise won't be there. So as normal it will goes. So this is called as motoring curve. Now we will came to know three stages. First stage from A to B, that is the initiation of flame. From B to C, that represent the flame propagation, and C to D, that represent third stage, that is the afterburning stage. So in the first step, as the initiation of a spark take place, it has to produce the flame nucleus. From the flame nucleus, it has to produce flame front. That means separation between the burned gas and the unburned gas. So it is purely chemical reaction between the spark and the fuel. So once that separation layer produced, that means only few amount of fuel which is nearer to the spark plug. So that fuel only it is burned during that stage, during this stage. So pressurize won't be there, much pressurize won't be there in this stage. So what will happen once the flame front is produced, only few amount of fuel is burned, only about 5% of heat will be released during this stage. Once flame front is formation of flame front is finished, it will enter into the next stage, that is the flame propagation stage. Once flame front is produced, it has to travel entire distance in the combustion chamber. So what will happen? It will encounter more amount of fuel. It will cover the more amount of fuel, and fuel will be burned. So it will produce us the heat. It will produce us the heat. And so during this stage, maximum amount of heat will be produced. That is around 90 to 95% of heat will be produced during this stage. So that heat will be transferred into expansion. That means power will be produced. So you can see over here your maximum pressure. This will happen just after TDC. Remember, whenever you draw the diagram, make sure that the point C, wherever the maximum pressure is happen, that should be after TDC. Initiation of spark will be before TDC only, but maximum pressure should be after TDC. Usually it is around 10 to 15 degree after TDC. 10 to 15 degree after TDC, you will get the maximum pressure, and your heat release rate will be maximum around 8 to 10 degree after TDC. You will get the maximum heat release rate. So once it reaches maximum pressure, then pressure will keep on decreases because you are already entered into the expansion stroke. So volume will increase, so wherever the unburned gas will be there, that also produce some amount of heat. So amount of heat percentage during this stage will be around 5%. So it may go in and around 5% stroke. So this is how your combustion will occurs in a SI engine. So three stages. One is the initiation of flame, then flame propagation, then we have the afterburning process. So I think you have understood this concept, that is the combustion of SI engine, three stages. So if you have any kind of queries, you can ask with me with respect to combustion of SI engine, because this flame propagation part, still lot of things will be there. So this may happen. This is, I am talking about just one cycle. This one cycle in actual case, it will happening in a fraction of second. So you may talk about 1800 rpm, 2000 rpm, 4000 rpm. That means for 4-stroke engine, 1 minute we have the 200 power strokes. 200 power stroke. If it is 4000 rpm means revolution per minute. For 1 minute we are having the 2000 power strokes, or 2000 combustion will take place for 1 minute. 2000 times this type of cycle will be there for 1 minute. So it is very fraction of second. You have to take care of all those things. So lot of things will be there, because chemical aspect will come into picture over here, and we have to so many factors how it will affect fuel air ratio, compression ratio, flame speed, types of fuel, so many other aspects, engine size, combustion shape or combustion chamber shapes, all those things will come into picture. So many aspects will be there. In brief, I have explained the combustion of SI engine. If you want more knowledge about this one, you can refer any IC engine test book. Richard Stone is the very good book of IC engine, which is published by SAE Publishers. Next, once you came about a normal way of combustion of SI engine, then next we should know abnormal way, means abnormal combustion, how it is taking place. So abnormal combustion means spontaneous combustion of the fuel without initiation of spark, or without initiation of some way of combustion. So fuel will ignite itself. So that kind of combustion is known as abnormal combustion. So this type of self-ignition of fuel without a flame, or without any means of initiation of flame, is known as auto-ignition or self-ignition. We will call it auto-ignition. So the temperature at which this self-ignition is take place, or auto-ignition take place, that temperature is known as self-ignition temperature. That means without initiation of combustion, fuel will burn. So that temperature, at what temperature fuel will have its own self-ignition temperature. Every fuel is having its own self-ignition temperature. That fuel, when it reaches that temperature, it will ignite by itself. So it should have several conditions, because it should be in the ignition limit. First of all, whenever that fuel. So whenever that is there in ignition limit, when it reaches that temperature, then that fuel will ignite by itself. That is known as auto ignition or self ignition. So that temperature is known as self ignition temperature. Whenever that happens, pressure and temperature abruptly increase, or abnormal way your pressure will increase or temperature will increase because there will be sudden release of heat energy or chemical energy of the fuel will take place. So hence very important to know about abnormal combustion, because whenever that abnormal combustion will occurs inside the combustion chamber, it will affect the component of ICE engine, especially piston, cylinder liner, then compression rings, then cylinder head. So it will reduce the life of the engine. So your engine life will be reduced if abnormal combustion is occurring inside the combustion chamber. So we have to avoid that one. So what are the conditions, and first we should know how it will happen. So before that we will just go through that this thermal efficiency, whatever you are talking, how much power is produced or how much heat is supplied, from that how much work has been converted in SI engine. So this will depends upon compression ratio mainly. So if more compression ratio means more efficient engine will be there. So and so we can check in a diesel engine we are having higher compression ratio, and so it is more efficient, but petrol engine is having lower efficient. Why we are kept that petrol engine in the lower compression ratio? Because of this reason, that is the knocking or abnormal combustion in SI engine. Because of that reason, we are restricting that compression ratio up to certain limit. We know that compression ratio, increasing the compression ratio, it will increase the thermal efficiency, but because of abnormal combustion, we are limiting that compression ratio for a particular value. Similarly for your diesel engine also, we are having certain range of compression ratio for diesel engine also, for SI engine also. So the maximum pressure of the cycle will increase. That means pressure will increase with increase in the compression ratio. So if you increase the compression ratio, obviously the design concept, or we will have the weight of the engine will increases and cost of the engine will increases. So many problems will come into picture. Next very important thing, as the compression ratio increases, the combustion of the fuel take place in abnormal way. Sudden pressure rise or sudden deterioration of the parts, engine parts will take place, and it will produce as the metallic sound because of high pressure impact on the piston, and it turned as the knocking or pinking of the engine. So these are the problems will arise, and life of the engine will reduce. So we have to limit that compression ratio because of this abnormal way of combustion. So knocking, before going to our process, what do you mean by knocking? That it means auto ignition of the fuel at the farthest end in the combustion chamber. That means one spark plug is located in one position. Once a spark plug is located, flame will be produced near the spark plug because the spark is producing the ignition. So flame front will be produced near the spark plug, and that flame front has to travel the farthest end in the combustion chamber. So when it travels the farthest end, the unburned gas over there, it may have reach auto ignition due to compression ratio or some other reason, or some due to earlier combustion products might be there. Due to several reasons, it may produce combustion in the farthest region. So there auto ignition will take place. So this flame wave collide with each other due to high pressure, and it will affect the piston or any other component in the engine. So this rapid release of energy due to auto ignition, so we are producing the high compression ratio wave, high pressure compression pressure waves that will causes vibration in the engine or some kind of abrupt noise. So that is known as knocking or detonation. That means the motion of high pressure compression waves inside the cylinder causes vibration of the engine parts and tinkling noise, and it is known as knocking or detonation. So that is nothing but two waves are colliding each other. One is the normal wave which is coming from the spark plug, and one more is the auto ignition. Due to auto ignition of the fuel, one more wave is coming from the farthest end. So these two waves will collide with each other, and it will forms the one sound or a pungent sound. It will produce a and vibration of the engine will take place. So that is known as knocking or detonation in a SI engine. Actually it is going. See, if we can see over here, normal combustion. Say A is the spark plug and B is B to C. It is the flame front, and normal burning charges. Here it is the charge, that is fuel and air mixture. This is D is the farthest point, or which is maximum distance from your spark plug. The D will be the maximum distance from your spark plug, or we will call it the farthest distance from the spark plug. So in the normal way, what will happen? So once initiation of spark plug initiated the flame front, this flame front will travels towards the farthest end. So this B to C, it will start from here, it will propagate, and it will reach the D. So this is how normal combustion will take place without detonation. So we will get a smooth pressure curve. That means we won't get any kind of auto ignition over here. So during abnormal combustion, what will happen, sir? During this flame front propagation from the spark plug to the farthest end, what will happen? Initially we are in the compression stroke only, so it is compression is keeps on increases. Meanwhile, this flame front, whatever is there, BC. So what will happen? This BC flame front, or we will call BB over here in the normal combustion BB, what will happen? It will compresses the unburned gas. Remember, this BC or BB, it will compresses the unburned gas over here. So what will happen? While compression, what will happen? Your pressure and temperature will increase. So if this fuel reaches that self-ignition temperature, remember, during compression of the flame front of unburned gases, if it reaches self-ignition temperature, then it will ignite by itself over here. So what will happen? One more wave will be produced over here, combustion wave, or one more flame front will be produced over here. So one flame front over here, one more flame front over here, which will collide each other, and it will produce us the more vibration, or two waves collide with each other. What will happen? Effect will be huge. So in this way, it will affect your piston and several other parts, cylinder liner or cylinder head, wherever this collidal of waves will take place. So what will get? Abrupt pressure rise will be there. So we won't get the smooth curve like this, we will get the abrupt pressure rise in the curve. So that will affect your several engine parts. So this type of combustion is known as abnormal combustion. We will call it as abnormal combustion, or we will call it a detonation or knocking in SI engine. I am talking particularly about SI engine. So this is about SI engine, how the knocking or detonation will take place because of unburnt fuel. This whatever the already produced flame front will be there, that will compress us the unburned gases. So these unburned gases at the farthest end may reach self-ignition temperature. That will also provide one kind of a flame front. These two flame front will collide with each other, and it will form the pungent sound, or waves, or collidal of two waves will form the abrupt change in the pressure rise. So we won't get the smooth curves, we'll get the like this curves over here. So this is known as detonation or knocking in SI engine. So This is how detonation will take place in a SI. So what are the effects? As already I told, it will cause heavy vibration and creates undesirable noise. Auto ignition may, what will happen? It may overheat the spark plugs. Once the spark plug is overheated, what will happen? It will be in the hot temperature region. So next charge in the next cycle of the compression stroke itself, pre-ignition of the charge will take place, hence power will be lost. So during the compression stroke itself, we will produce the combustion of the fuel take place, hence power will be lost. And more heat means we have to take that heat by the cooling water. Effectiveness of the cooling water will be more. Heat dissipation rate should be rapid. The engine parts are subjected to the high pressure waves, which will cause us the damage of the component parts. So this is the diagrams of piston where it is damage caused due to high temperature and high pressure, that means from severe knocking. So this is how your piston will be damaged due to knocking. This is the piston crown damage, and this one is the cylinder head gasket, damage of gasket, and this is how cylinder head will get damage. So you just check the photograph of damage of engine components, which will reduce the life of the engine. Next, factors affecting the SI engine. Several factors are there. I will go through very quickly about this one. So first one is the fuel characteristics. In these fuel characteristics, we have the molecular structure, self-ignition, temperature, flame velocity. Molecular structure means unsaturated hydrocarbons will have a greater resistance for knocking than that of saturated hydrocarbon. Self-ignition temperature, as already I explained, the fuel should have a high self-ignition temperature so as to avoid the knocking. If it is having less self-ignition temperature, that means it will ignite by before the end of compression itself. So fuel should have a high self-ignition temperature when you selecting the fuel. Flame velocity should be more, means it has to very fast, it has to travel the entire combustion region, entire combustion chamber, it has to travel very fastly. So flame speed or flame velocity should be more for that particular fuel, and this flame velocity once again dependent on several factors which I explained in the second slide. So you go through that one once again. Next we have the condition of the charge. One is the air fuel ratio. Air fuel ratio, as already I told, whenever flame velocity is near to the stoichiometry or slightly richer side, we will have the higher flame velocity, and so better anti-knocking quality will be obtained whenever the air fuel ratio is in a richer side when compared to that of linear side. Density of charge, that means if you are applying supercharger or turbocharger, density will increase, which means knocking tendency may increase if the density of charge increases. And temperature of the charge, once again, initial temperature means very easier to ignite, that means self-ignition temperature, it will reach us very fast, hence knocking will be very high whenever the temperature of charge will be higher. Next, compression ratio. In the compression ratio, as already told, higher the compression ratio, which will lead into the higher knocking tendency. Hence, compression ratio should be as low as possible so as to avoid the knocking. Compression ratio, one way in this two types are there. One, dilution of residual gases and valve timing. So dilution of the residual gases will reduces the knocking tendency, and this we can reduce the knocking. So valve timing means very important aspect. Valve timing means one particular timing, that means spark will produce before the TDC. So for a particular engine, it is designed for a particular timing, say 12 degree before TDC, we can assume. So 12 degree before TDC itself, your spark will be ignited. So if you want to increase from 12 to 14, that is called as advancing the timing. Or if you want to decrease, that means from 12 to 10, then it is called as retardation of the spark timing. Means you are delaying the spark timing from 10 to 12 to 10, or 12 to 14 means you are advancing the timing because you are in the compression stroke. Remember, just try to understand that concept, advancing and retarding. So if you advance the timing from the normal timing or prescribed timing, then what will happen? So you will be giving the more time for combustion, and knocking will be, the rate of knocking will be high during that case. So retardation of the valve timing will give the lesser tendency for the knocking, and but you can't retard too much because power loss will be very high. So hence we have to get the optimum timing for knocking tendency. Next, ignition in this location of spark plug, which is very important. We have to locate the spark plug in such a way that flame has to travel entire region of the combustion chamber. You should not very late for the furthest end. If it is very late to reach furthest end, then the knocking tendency will be very high. Also, we have to make sure that the spark plug, it has to locate away from the exhaust valve, because exhaust valve will be always operated on the high temperature region. Hence, if it is located near to exhaust valve, then pre-ignition of the charge will take place, hence tendency of knocking will be very high. So we have to locate the exhaust valve in such a way that it should be away from the exhaust valve. Spark plug will be located in such a way that it should be away from the exhaust valve, and it has to reach farthest end, means the more distance it has to travel within a quick time. Then spark timing already I discussed in the previous case. Engine speed, increasing the engine speed will increases the turbulence and knocking tendency will be reduced. So engine speed, increasing the engine speed will reduce. Engine load, while increasing the load, what will happen? Cylinder wall temperature will be increases, so knocking tendency can increase. So we have to maintain a particular lesser load from the maximum load, so that we can avoid the knocking tendency. Next, rating of the fuel, very important aspect. Rating of the fuel means how much that fuel will resist in knocking tendency. That one number will give the fuel, so that number will indicate how much it will resist for knocking tendency or detonation tendency. How can resist that fuel? So if the number is more, that means it is having the greater resistance for a knocking, greater resistance for a tendency to knock. So we have two such fuels. One is the isooctane and N-octane. So comparing our selected with respect to these two fuels, we will give the number that is called as octane number. So in this two fuel, isooctane, which will offers greater resistance for knocking or detonation. So therefore, it will assigned as a rating of 100 octane number. Isooctane is rated as 100 octane number. Similarly, N-octane, which will have the detonate as soon as whenever it is inserted into the engine. So it is given as rated as 0 octane number. That is, it doesn't have a resistance for knocking. So it will knocking will be very more in N-octane. So that will be assigned as a 0. So whatever now selected fuel we can give with respect to these two references. So it is possible to match knocking tendency of fuels, blending these two fuels in a different proportion. For example, if you can say, if your selected fuel is having the octane number of 80, means that fuel has the same knocking tendency of 80% isooctane and 20% N-octane. So whatever combination of this fuel having the knocking tendency, same knocking tendency will have that whatever you have selected fuel. That is the meaning of that number. So in this way we will rate the SI engine fuels. So for example, if you have the octane number of 50, that means that fuel is having the same knocking tendency when 50% of isooctane and 50% of N-octane mixture is formed. So this is how we are rate the SI engine fuel in terms of octane number. So SI engine fuels always will rate in terms of octane number. So this knocking tendency of an engine increases with the increase in the compression ratio, already we have discussed. So here second sentence is very important. The higher the octane number, which will have the greater resistance to knock, because higher the octane number, that represents higher volume of isooctane. So isooctane will have greater resistance, hence that fuel will also have the greater resistance for the knock. Hence whenever the greater resistance will be there now, so you can increase the compression ratio without knocking. So if you increase the compression ratio, that means we can get the higher efficiency. So octane number will be important for the fuel. If you are having a higher octane number, then you can use that fuel for the higher compression ratio. And power output and specific consumption rate are function of compression ratio. So those can be considered as a function of octane number. So higher the octane number increases the efficiency, because higher the octane number you can use for higher compression ratio, hence efficiency of the fuel can be increased. So for a given engine there will be critical compression ratio beyond which knock occurs. So we know that already I have told in the previous slide, that is if you select compression ratio for SI engine, we have generally 6 to 10 or 6 to 9.5, we can say 6 to 10 we can say compression ratio, and for diesel it might be 10 to 14 to 20, 21. So that range only you have to use. Beyond that range the knocking will be very high, so hence damages the piston or any component of the engine. So particular range will be there for that particular fuel. For diesel it is 14 to 21, and for your petrol it is 6 to 10. So if you want to increase the compression ratio beyond this one, then this octane number has to help. So you should have a more octane number, then only you can use that fuel for a higher compression ratio for any given engine. So we will have certain critical compression ratio beyond which knocking will be more, or knocking will be occur in that engine. So that compression ratio is known as HUC, or highest useful compression ratio. So particular given engine, that critical compression ratio, till that knocking may not be occurring inside the engine. Beyond that compression ratio, your knocking may increase. So this critical compression ratio, it is known as highest useful compression ratio, HUCR. This is known as. So this is how we will rate the SI engine fuel. So this will complete the concept of SI engine. Very briefly we have explained, very brief in the syllabus. So many things will be there, you can refer if you want very interesting, if your field is engine field. So you have to refer either Richard Stone book, ICE Engine by SI Publishers, or one more book is there we will call God of ICE Engine, that is John B. Ehud textbook. Very informative book will be there in ICE engines, so you can refer that book also.